My name is Claudio Barbieri da Cunha. I'm a civil engineering as my undergrad degree, and I also have master's and PhD degrees in transportation engineer. I'm a professor, we call it full professor in Brazil, which is profesor catedrático in Spanish, at Universidade de São Paulo, Department of Transportation Engineering. When I was undertaking my undergrad career, I liked very different topics in civil engineering. I liked the sanitation, and I had the chance to do internship in sanitation, in structural engineering. But when I took the undergraduate courses in transportation engineering, especially transportation planning, I kind of fell in love with this field. I love this area because it's an area which is engineering, but it's not typical engineering in the sense that you are calculating things, in the sense that you are doing mathematics stuff and etc. You have to interact with a lot of people from different backgrounds. You have to understand people's behavior in transportation engineering, and I find this really, really very passionate. Until I finished my undergrad course, I had no idea what operations research, mathematical modeling meant. I had no idea. I started working in a consulting firm, a very large one, 800 engineers, 2,000 employees, and I was doing projects in transportation planning. Then when I came to start my master's, I took my first course in optimization, linear programming optimization, and algorithms. And I fell in love with this area. But I fell in love with this area not in the same ways as possibly mathematicians would do, because they are in love with the mathematical models. I'm not in love with the mathematical models. I'm in love with solving difficult problems in which the number of alternatives, the number of possible alternatives or solutions is very high, and we have to apply some sort of tool, mathematical tool, that will help us find what we call the optimal solution. I'll give you two examples. One example is something that we applied in the city of São Paulo. The city of São Paulo had one emergency medical service, which are the ambulance that we dispatched when an accident happens, someone got hit by a car or fall on a bike, and etc. And the average time, response time, was 30 minutes. So you would expect the ambulance to arrive, in average, 30 minutes after the call. That's too much. So the responsible for this area in the municipality of São Paulo was wondering what should be done to improve the service. And the obvious answer to this question is to buy more ambulances. But he was not convinced that the right answer would be to buy more ambulances. He suspected that the ambulances were also not well positioned to be ready to respond to the calls that they received. And he had an idea that if we could have some movable bases where the ambulances would stay temporarily, it would improve the service. So we collect data from calls, 1 year data. We analyze this data to understand what would be the call patterns throughout the day and throughout the different days of the weeks. Sundays are completely different from Mondays or Tuesdays or Wednesdays, the different times of the day, and etc. And we developed an optimization model to find the best configuration of the ambulance stations, as well as the number of ambulances that should be placed in each station, and how those ambulances would move to different areas throughout the different days. We could save the time, the response time. We could reduce it for about 15 minutes. And the city of São Paulo got a very important prize among the emergency medical services systems as one which had a role example in improving their service. And the other funny thing is that we selected an algorithm, an optimization algorithm, that tries to mimic how bees, honeybees, how they search for source of food. So it was also easy for the person who hired us, our group in the university, to explain how this mathematics was working. We have some mathematical models that will try to mimic how bees, which are supposed to be clever insects, search for food for producing honey. Regarding the future of my area and the use of AI, I must start saying that I'm not an AI expert, okay? So I'm not really doing a lot of research in AI. I think AI is something that has been applied wonderfully to identify patterns, to identify coincidence, and etc., much better than other tools. On the other hand, we still have some optimization problems in which AI may not be very helpful unless you have a very large pool of good solutions that will help you identify patterns of very good solutions. And I'll give you an example of a competition that MIT, Massachusetts Institute of Technology, in their field of last mile distribution, they did a couple of years ago. They offered a large database of very efficient delivery routes that were delivering packages to doors. They wanted to analyze this data and provide some sort of algorithm that would help schedule delivery routes better. If I'm not mistaken, the winning solution is something that would combine AI, good patterns and etc., with some sort of optimization models so that you could tailor the optimization to find good solutions, taking into account some soft constraints. We say soft constraints, those constraints that cannot be translated into mathematical values, mathematical variables. So I see a very promising future for AI together with other tools that we have in place and we have been using for years and decades. Regarding research in transportation across the world, I think we have very amazing institutions that are doing excellent jobs in different parts of the world. We have very important institutions in North America, in the United States, in Canada. I had the chance to be at University of California, Davis on a Fulbright chair position and stayed there for 4 months, and I could see how impressive is the work that they are doing there in terms of sustainable transportation. They have around 70 PhD, not students, they have 200 students, and they have 70 PhD researchers doing researches in different parts of sustainable transportation. Why is that possible? Because they can somehow compete for resources that can help them afford such a big center. I see other centers similar in Europe. For instance, here at UPM, the transit lab held by Professor José Manuel Vassallo has also impressive work in terms of doing applied research that can be applied to practical problems. I see our field, the future of our field as trying to be connected and be very close to the real problems society is facing or is going to face, so that we can help improve our lives that people have in cities in different parts of the world. So what I see now is that academia is looking more closely to the real problems that the world is facing. And I find this is very interesting, this is very nice. I understand that not all areas would be able to address this in this way, but we ourselves as professionals in engineering and other practical professions should not be or should not disregard the practical aspects of the problems that we face in society. I think that people have to follow their passion, they have to do what they're passionate about, because work becomes pleasure when you are doing what you like. I like my life as a professor in a university. I find it very funny to interact with students, undergrad students, graduate students. I like to interact with companies. So I think that students in general, undergrad level or graduate students, masters or PhD, they should basically try to pursue their passion, what they like more, what they do as a pleasure. Because I know that's not easy to do that all the time, and we don't have pleasure all the time, but if you think about your past, like my past, and I say, what I've been doing for, I completed my undergrad degree in about 42 years ago. So what I've been doing with my life? I've been doing what I like. I have fun most of the time. Of course, I have things that I don't like much, but I have fun. So I think that students should try to find a position in which they feel excited about it. They feel passion, because this will make them work harder, this will make them study harder, and this will make them better professional, and this will make them not bored. And I think we need people that are able to find themselves with their passions. If I have to stay at home and I have nothing to do, and I will probably do something related to my research, because for me it's not a burden. For me it's something that it gives me pleasure. During the pandemic, we were all at home, we could not go out, we could not see people, etc. It was very funny, because I decided that I would go back to coding, programming coding. This is something that I was not doing pretty regularly. I do not do pretty regularly because I don't have time, but I was doing coding myself. And they say, are you nuts? On a Saturday afternoon, you are coding? Yes. Instead of watching Netflix or something like that, those series that I was kind of bored, I was doing something different that gives me pleasure. So I think that we must find things that gives us pleasure. And in transportation, we also have to understand what are the real problems. We have to interact with people. We have to talk with people. I love following deliveries with drivers, truck drivers. I love going with them, understand what they do on a regular basis. When I travel, I always try to use public transport, because I want to understand how it works in different cities. And by the way, Madrid is really amazing. It's one of the best cities in Europe regarding public transport in general. It's very convenient, very easy to use, to ride, etc. You have an amazing city here. Nowadays, there is that major, important, relevant concern about climate change and how we could mitigate the problems of heating, etc. So in many places we are considering switch vehicles to vehicles that are less aggressive to the environment, that produces less emissions. So what I've been doing now is trying to understand how to employ these vehicles in the best manner, especially for freight transportation. Because different from public transportation, buses would run, let's say 100 kilometers, 200 kilometers per day, so they will be able to be recharging the vehicles during the night, during the night in which the vehicles are idling. On the other hand, trucks, especially not trucks, small trucks that are delivering cities, but those trucks that are traveling intercities, they also have to recharge, and it's not really quite clear how it's going to work in different parts of the world. While in Europe you have an amazing infrastructure that's been built in terms of electric chargers, etc. In some parts of Asia, particularly in China, they are also building an amazing infrastructure. In other parts of the world, in developing countries like my country, Brazil, it's not clear if this infrastructure will be ready in a short or mid period of time. So we have to understand what would be the priority, where we start to improve this. So me and my colleagues in my university, we are trying to address this type of problem to guide our governments, our society, to understand and select the best alternatives that would provide the best results.
Give us some.
When you say electrifying trucks, you have some different types of trucks. You have battery-operated trucks. So battery-operated trucks, you have to recharge it. Or you can swap batteries, so you can remove the battery from the vehicle and put another battery. This may work in some places, but I'm not sure if it's gonna work in places like developing countries in South America, or maybe in Africa, or not so well developing countries in Asia as well. So basically, the other possibility is vehicles whose electric power is generated by hydrogen. Okay? The problem with hydrogen is that it's very difficult for you to transport hydrogen, for it to be loaded into vehicles. What we are doing now in my country is Brazil, in particular, we are exploring how to convert ethanol into hydrogen at the gas station, at the petrol station level. So instead of moving hydrogen in a very low temperature with some vehicles that are very expensive, we would be moving ethanol, and we would have a catalytic chemical transformation in which this ethanol would be transformed into hydrogen at the gas station, the fuel station level. So we would be able to load freight vehicles with that. However, we may not have ethanol for all the truck fleet. We may not have ethanol available in the neighborhoods of the cities where they require it. So what we are trying to start studying now, what would be the best use of ethanol for freight vehicles, where exactly? What would be the best way to use it, considering that it's a resource that is scarce, has a lot of limitations in terms of the total productions, in terms of the distance to be transported. Ethanol is also expensive to be transported, etc. How we can understand all this and how we can provide a transition plan for electric vehicles, freight vehicles in large countries like Brazil. But the thing is, developing countries are, we don't have resources for investments. The government does not have resource for investments. So I would see this sort of transition to move much more slower than in other parts of the world. Okay, it's amazing how China build things and make investments, etc. But it's not our reality. Yep. Let's say for us to from the initial plan of subway or metro stretch segment, for it to be ready, it takes 10 to 15 years. We have to learn from the mistakes that we make in the past. Brazil hosted the football World Cup in 2014. And we decided in our city of São Paulo to build a monorail that would be an effective way to move people from one of the airports to one of the stadiums. Why monorail? Because you don't need to do it underground. It's going to be less costly than a metro. It would be easily built because you don't have to remove houses, etc. I must tell you that this monorail did not get ready for the World Cup, and it is not yet ready. It has, from the World Cup, 11 years have elapsed, and it's not ready. We have some skeletons there, the infrastructures, you know, the pillars and etc., but it's not ready. So it's difficult to make investments in transportation because it impacts a lot of people. It costs a lot of money. So we have to understand how to make the best decisions. That's why we all are here, that we are people that are working this stuff.